Hi guys, welcome back to Maths Lessons with Miss Pine. Today we are doing grade 10 revision paper 2 and we are starting with trigonometry. So up here we have a question from November 2015 and it is question 4. So we are given a diagram with two triangles, PQR and triangle SQR. Both of these triangles are right-angled triangles as indicated, and we are given that the length of PR is equals to 26 units, the length of PQ 24 units, QR 10 units, SR 6 units, and QS 8 units. Now we are requested to determine the values of the given ratios without the use of a calculator. So if we cannot use a calculator, then we can use SOHCAHTOA, because we are dealing with right-angled triangles, so we can use our SOHCAHTOA. Now the first question, 4.1.1, we have to determine the value of tan angle P. So we locate our angle P, which is up here, and we notice that angle P, it is located in triangle PQR. So we are only going to focus on triangle PQR for now. So we write our definition of tan, which is opposite over adjacent. Now the opposite side of angle P is 10. The adjacent side of angle P is 24. So tan angle P is equals to 10 divided by 24. 10 over 24. Right, let us go to the next one. Sine SQR. Sine angle SQR is this angle over here. So we write the definition of sine is opposite over hypotenuse. Now we notice that angle SQR lies in the small triangle SQR. So we are only going to focus on triangle SQR. Now the opposite side of angle SQR is 6 divided by the hypotenuse. The hypotenuse, remember, it is the longest side. So the longest side of angle SQR is 10. So the sine of angle SQR is equals to 6 over 10. Right, let's go now to 4.1.3, cos theta. Where is cos theta? Where is theta? Here is our theta. So we write the definition of cos, which is adjacent over hypotenuse. This is equals to, we want the adjacent side of angle cos. Before we go there, we notice that our angle cos is located in triangle PQR. So we will only focus on triangle PQR. Now the adjacent side of of theta is 10. So this is 10 over the hypotenuse, which is the longest side, it is 26. So cos theta is equals to 10 over 26. Now 4.1.4, we have sec SRQ. Sec angle SRQ, angle SRQ. It is the whole of this angle, SRQ. But now we have a sec. Remember, a sec is an inverse function. It is an inverse function of cos. Since we know that cos is adjacent over hypotenuse, now means sec is equals to hypotenuse over adjacent, because it is the inverse of cos. Now let's go to our angle SRQ. So the hypotenuse of SRQ, which is the longest side, is 10 divided by the adjacent side of angle SRQ is 6. So sec SRQ is equals to 10 over 6. Now moving right along to 4.2, determine the value of cot theta divided by sec angle RQRS. Angle QRS, it is still this angle, and cot theta is this angle. Okay, now cot is also an inverse ratio of tan. So the inverse ratio of tan we know that is opposite over adjacent. So now we'll have adjacent over opposite divided by cosec. Cosec is an inverse function of sine. So since sine is opposite over hypotenuse, it means cosec will be hypotenuse over opposite. Right? Now this can guide us to find the proper values. The adjacent of theta. The adjacent of theta we have is 10 divided by the opposite of theta. The opposite of theta, which is 24. Adjacent, opposite. The opposite of theta is 24. Divided by hypotenuse over opposite, divided by cosec angle QRS. Here is our angle QRS. The hypotenuse of angle QRS, remember it is the longest side of triangle QRS. The longest side of triangle QRS is 10 divided by the opposite of angle QRS, which is 8. Now this is equals to, we have a division sign, we change it to multiplication. So we have 10 over 24 times, when we change division to multiplication, you know from grade 8, the second fraction interchange, denominator becomes numerator, numerator becomes denominator. And then this is 10 times 8, 10 times 8, which is 80, divided by 24 times 10, which is 240. And the simplified value is 1 over 3. So this is how we find the values of given ratios without a calculator. We just analyze the given diagram and work with triangle by triangle. Focus on one triangle at a time.